7-4 Division Properties of Exponents. In this lesson, we will learn to divide powers with the same base by subtracting the exponents. Let's start by using the expanded form, or what we have also referred to as the repeated multiplication form, to simplify a problem to then understand the shortcut. 5 to the power of 7 means 5 times 5 times 5 times 5 times 5 times 5 times 5. 5 to the power of 3 means 5 times 5 times 5. So when we see this expanded and we start simplifying by dividing a 5 by a 5, a 5 by a 5, a 5 by a 5, each becoming ones, which keeps the rest of the value the same because multiplying by 1 does not change the value of a number. We now simplify this as what? 5 times 5 times 5 times 5. That's just 5 to the power of, how many 5s are there? 4. So what you can notice now is 7 minus 3 gives us this 4. Now let's take a look at a few examples where we apply the shortcut. 10 to the power of 9 divided by 10 to the power of 4 is the same as 10 to the power of 9 minus 4. And that results in 10 to the power of 5. Similarly, 10 to the power of 4 divided by 10 to the power of 9 is equal to 10 to the power of 4, starting with the numerator exponent, minus 9, the exponent in the denominator. This time we get 10 to the power of negative 5. And recall that when you get a negative exponent, you want to change that into a positive exponent by moving it to the opposite side of the fraction bar, which currently there was an invisible fraction bar here, so we drop this down into the denominator to make that a 10 to the positive 5. And now we fill in the top with a 1. Another way to think of this problem that might be easier is, where are there more 10s? Are there more 10s in the numerator or the denominator? You would agree that there are more 10s in the denominator. How many more 10s? There are a total of 5 more 10s in the denominator than in the numerator. Similarly, in the first one, where are there more 10s? There are more 10s in the numerator. So we have 10 to the power of 5 on the top in the numerator because there are 5 more 10s on top. Now let's deal with rational exponents. In other words, fraction exponents. The process is the same. The only difference is we have to find common denominators when the denominators are not the same. So we get x to the power of 2/3 minus this 1/2 because we are subtracting the exponents to simplify. And now if I rewrite these with common denominators, I have to ask myself, what do 3 and 2 both go into? They both go into 6. So I would multiply this by 2 to give me the 6 here. And we multiply by 3 here to give us the 6 in that second fraction. So our new fractions are x to the power of, we get 4 over 6 minus 1 times 3 is 3, 2 times 3 is 6. And now when we simplify, we get x to the power of 4 6 take away 3 6, that's 1 6. In the second problem that involves rational exponents and also variables, we have x to the power of 3 first, divided by x to the power of 6, which means we have x to the power of 3 minus 6. So we're subtracting those two exponents. And secondly, we have y to the power of 2/5 divided by this y to the power of 1/5, which means we're subtracting these exponents. X to the power of 3 minus 6 becomes x to the power of negative 3. And here, 2/5 minus 1/5 is 1/5. Now, we can deal with the negative exponent by taking this power down into the denominator. So I'm creating a fraction bar and bringing this down into the denominator to make this exponent positive. This power stays exactly as it is and stays right in the numerator because the exponent is already positive. That's simplifying with exponents when you're dividing.